Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Purification and Characterization. In this, today we are going to discuss about one of the purification technique, and which is very important technique, that's called as chromatography. Let us start the session. Chromatography, right? This method is used for separation of mixture into their components. If there is mixture of substances, to separate them into its components, this method is useful. And not only that, it is used for purification of organic compounds, and also test the purity of compounds. So chromatography is used to separate a mixture of components, and it is used for purification of organic compounds, and it is also used to test the purity of the compounds. Whether it is pure or not, you can test by using chromatography. See, chromatography is obtained from Greek word chroma, means color. Graphy means writing. Why they have mentioned this? See, this method was first used for the separation of colored substances found in plants. So in plants there are colored substances. To separate them, it was first used. This chromatography technique consists of two phases. How many phases are there? Two phases. Okay, one is stationary phase. What is called as a stationary phase? The stationary phase can be either solid or liquid. Chromatography involves two phases. Okay, we will learn what are those phases, how those phases play a role in the chromatography and all those things. Second one is mobile phase. What is that? Mobile phase. It can be either liquid or gas. So chromatography involves two phases. One is stationary phase, another is mobile phase. Here stationary phase of large surface area. Stationary phase will have large surface area, while the second one is moving phase, or which is also called as mobile. Mobile means moving phase, which is allowed to move slowly over the stationary phase. Stationary phase does not move. Who moves? Mobile phase or moving phase moves over the stationary phase. Okay. Mobile phase moves over the stationary phase. So stationary phase is either liquid or solid, while moving phase may be liquid or gas. So the basic, based on the principle involved in chromatography, chromatography is classified into two types. One is adsorption chromatography, another is partition chromatography. Adsorption. So what is meant by adsorption here? You have to learn what is meant by adsorption. Adsorption means surface absorption. Surface absorption. Let us take some activated charcoal. What is that? Activated charcoal. So this is activated charcoal. Let us take activated charcoal. So it's being activated by heating to a certain temperature, it gets activated. So when there are any gases, here are gases for example. These gases, in the presence of this activated charcoal, this gas get attached on the surface. They don't enter into it, but this gas attach on the surface. So attachment, surface attachment is called as what? Adsorption. In simple language, what is meant by adsorption? Adsorption, AD we are writing. Adsorption means on the surface, if any substance adsorb, and that is called as a adsorption. So this activated charcoal now called as what? Activated charcoal now called as what? Adsorbent. This gas is called as what? Adsorbate. Adsorbate. The substance which attaches on the surface of adsorbent is called as adsorbate. The substance which adsorb other substances is called as a adsorbent. So surface attachment is called as what? Adsorption. Based on the adsorption, we say such chromatography called as adsorption chromatography. And partition chromatography, in our syllabus we have only one partition chromatography, and that's called as paper chromatography. So we'll study what is meant by paper chromatography, what happens in that paper chromatography. So first let us go with the here adsorption. Now only we have studied what is meant by adsorption. We are studying adsorption chromatography. What is adsorption chromatography? Adsorption chromatography is based on the fact that different compounds are adsorbed on an adsorbent to different degrees. So all these substances will not adsorb to the same extent. Different substances will adsorb to different extent. Some adsorb more effectively, some do not adsorb more effectively. Depending upon their attraction, depending upon their adsorption capacity, different substances will adsorb to different extent. Okay, that is the principle here. Different compounds or different substances are adsorbed on adsorbent. Now we have seen adsorbent to different degrees, to different extent. You can also say that it is different extent. All the substances will not adsorb to the same extent. Okay, commonly used adsorbents are silica gel, SiO2 gel. So, commonly used adsorbents. Commonly used adsorbents. Okay, now only we have seen what is meant by adsorbent. What are those? Silica gel, alumina, Al2O3, silica SiO2, alumina Al2O3, like magnesium oxide, MgO, cellulose powder, activated animal charcoal. Here you see activated animal charcoal. Animal charcoal. Right? So these are generally used or commonly used adsorbents. When a mobile phase is allowed to move over stationary phase, adsorbent. Who is acting as adsorbent here among stationary phase and mobile phase? Stationary phase act as a adsorbent. What is that? Stationary phase. Already we have discussed that chromatography involves two phases. One is stationary phase, another is mobile phase. The stationary phase act as a adsorbent. Okay. The components of the mixture move by varying distances over stationary phase. Then what is adsorbate? What is adsorbate? The different components is called as adsorbate. You will see. So there are two main types of chromatographic techniques based on principles of differential adsorption. Based on adsorption, there are two chromatographic techniques. What are those? One is column chromatography, another is thin layer chromatography. Based on adsorption, two chromatographic techniques are there. What are those? Column chromatography, another one is thin layer chromatography. Right? Let us see details about column chromatography. Here we are seeing what? Column chromatography. Column chromatography. At the base you can see column chromatography in detail here. So it involves separation of a mixture over a column of adsorbent packed stationary phase in a glass tube, which is fitted with stopcock at its lower end. See. So this is column chromatography. Right. So what is this? So what is this? This is a glass tube. What is this? Glass tube. In this glass tube, you have stationary phase. You see, stationary phase. Already we have discussed that the stationary phase can be either solid or liquid. So adsorbent, stationary phase. So you have filled this with stationary phase. What are stationary phases? Also we have seen adsorbents, silica, gel, alumina, activated charcoal, cellulose powder. Anyone you can take. Let us take silica gel here. Adsorbent is silica, for example, silica gel. Now you want to separate a mixture. It contains three components. You are seeing here mixture of compounds which you need to separate them. You have to separate this mixture of compounds. What are those? A, B, C, for example. Three components are there. They are mixed. Now you have to separate them. That mixture which is to be separated is kept here over this at the top. Over the stationary phase at the top you are placing it. Now you have to separate this mixture into components. Then what you are doing? You are pouring some solvent. See here solvent. Solvent is acting as a mobile phase. What is this? Mobile phase. Solvent can be either liquid or gas. So whatever the solvent it is, you are placing it. You can place a single solvent or more than one type of solvent. A mixture of solvents also you can place here. So now when you are placing a solvent, either it is liquid or gas, let us take we are placing liquid here. Already we have studied that this solvent or mobile phase moves over stationary phase. Now what you find, this mobile phase slowly moves down, moves over it moves over the stationary phase. When it is moving over the stationary phase, along with that solvent, these components also move over the stationary phase. See now, in this you have ABC in the first diagram, second and third diagram, let us take. In the first diagram, if you see, all the components are mixed. When you come to second diagram, you see A is separated and B and C are still in the mixed form. A is separated. And still, if solvent is moving still down, solvent is moving over the stationary phase, along with the solvent, this B and C also moves. Now see in the third diagram, A, B, C all are separated. This is based on the principle of adsorption. Now, looking at this, which has more adsorption tendency? Adsorption tendency. Among this ABC, which is having more adsorption tendency, A has more adsorption tendency than B. B has more adsorption tendency than C. As A has more adsorption tendency, it attaches to the stationary phase immediately. Why? See, here A plus B plus C are there. A moved to very less distance. Why it is moving to very less distance? Because it has more adsorption tendency. It readily adsorbs to the stationary state. Which has least adsorption tendency towards the stationary phase, C. As C has least tendency of adsorbing to the stationary state, it moves some more distance because it is having less tendency when compared with A and B. Okay. Are you getting this? So adsorption tendency is distance moved from the original position. If I ask you, distance moved, who will move more distance? C will move more distance from its original state. Distance moved from its original state, original place, let us say. Here originally 3 are there. Which moved more distance? C greater than, B greater than A. As adsorption tendency of A is more, it moved to less distance. As adsorption tendency of C is less, it moved to more distance. So such type of questions are asked in PYQ. Such questions are asked in competitive examinations. Right? Now let us see. Here in the first diagram, if you see, the components of mixture are not separated. But in the third diagram, if you look into, all the components are separated. So by this method, did we separate the components of a mixture? Yes. We separated the components of a mixture. Let us see points. The mixture to be adsorbed on the adsorbent is placed at the top of the stationary phase. Here we have placed. An appropriate eluent. Eluent is nothing but a solvent. Okay. Which is a liquid or a mixture of liquids is allowed to flow down the column slowly. It is poured on this so that they slowly move down over the stationary phase. The most readily adsorbed substance, which is most readily adsorbed substance? A, are retained near the top. See, here it is at the top. A is at the top because it is more absorbing on the stationary phase. So it is readily attached, fastly attached. Surface attachment is called as what? Adsorption. And others come down to various distances in the column. So in this column, A is moving to a particular distance, B is moving to a particular distance, and C is moving to a particular distance. So they move to various distances. Recovery of the separated substance by using suitable solvent is known as elution. So after they get separated, we recover these substances. Recovering this, we will find what is A, what is B, what is C by using appropriate solvents. So what is A, what is B, what is C? Finding what are those substances is called as recovery of those substances. And that process is called as what? Elution. And the solvent is known as what? Eluent. Understood? In this, you will be asked, which component will travel more with the solvent? Which component will travel more with the solvent? C component will travel more with the solvent. For example, in PYQ it is given that if you open this valve, if valve is opened, so let us take if valve is opened, if all these are liquids, which comes out first? Which comes out first? Which comes out first? C will come out first. Who will come out first? The component C will come out first. Which will come out last? Which will come out last? A will come out last. Are you getting this? Such questions are asked. So you need to understand the concept. First, if you understand the concept, then you can. Let us move to the next part. So that is about column chromatography. Now we are looking into thin layer chromatography. What is that? Thin layer chromatography. In this thin layer chromatography, see, a glass plate is taken. See, this is glass plate. What? This is what? Glass plate. We are taking a glass plate. So we are coating adsorbent. That means stationary phase. So what is coated here? it is coated with a stationary phase. So this is all stationary phase, right? We have coated it with the stationary phase. Coated with the stationary phase, right? This is all stationary phase. So in this way, you can see it involves separation of substances of a mixture over a thin layer of an adsorbent coated on glass plate. So what is this glass plate? On this glass plate, you are coating stationary phase. This coating is what is stationary phase. Stationary phase, or it is also called as a, what is that? Adsorbent. Adsorbent, right? So the glass plate is coated with adsorbent. Example, adsorbents already we have seen, either silica gel or alumina, as a thin layer about 0.2 mm thick. And that glass plate coated with this adsorbent is called as a chromatography plate or chroma plate. What is that called as a chromatography plate or chroma plate? So now you want to separate a mixture. A mixture contains some substances like A, B, C. Okay. So you want to separate this mixture. Now what do? You are placing at the bottom here about nearly some 2 centimeters. You take and you place this mixture. You are placing this mixture, right? Mixture containing some 3 components, let us take. How many components? 3 components are there. You are placing here. Now this total is kept in a vessel containing solvent. What is present? You can find this diagram here, right? So at the bottom you are finding solvent, you see. Whether you are able to understand or not, again I am drawing. Okay. So what is that? Here there is a solvent. What is there? Solvent. This is solvent. So the solvent should not touch the mixture containing components. The solvent should touch the stationary phase, but the solvent should not touch this mixture. So what is this solvent? Okay. Solvent is also called as eluent. We have already studied, right? Now you see, the solution of mixture to be separated is applied as a small spot about 2 centimeter above from one end of TLC plate, thin layer chromatographic plate. Here we have placed like a dot. I placed like a thick line. You can also place like a thick line or a dot. So the sample dot contain components A, B, C, such like, which are to be separated. Now what happens when it is placed? The glass plate is placed in a closed jar containing the solvent. Eluent is also called a solvent. As the eluent rises up, the components of the mixture move up along the eluent to different distances depending on their degree of adsorption, and separation takes place. This is what we have studied in adsorption. Now what happens? This solvent moves over the stationary phase. The solvent is moving over this stationary phase like this. It is moving. Who is moving? Solvent is moving. Solvent is also called as what? Mobile phase. What is that? Mobile phase. So this mobile phase is moving over this stationary phase. When it is moving over the stationary phase, it will also move these components. What are moved? The components in the sample are moved along with the mobile phase. See, this mobile phase is moving over the thin glass plates over the stationary phase. When it is moving over the stationary phase, it also carries these components. When it is carrying the components, depending upon their adsorption capacity, already tendency we have studied. Some has more tendency, some has less tendency. Before we have seen that A is having more tendency than B, B is having more tendency than C regarding adsorption. As A is having more tendency, A will stop after moving some less distance. Okay, what is this? Let us take this A. Because A is having more tendency, let us consider that adsorption tendency. What is that? Adsorption tendency. So who is having more adsorption? Who is able to adsorb more? A has more adsorption tendency than B. B has more adsorption tendency than C. Adsorption tendency, the ability to adsorb, the ability to get adsorbed. So A adsorbed to the stationary phase more than B. B adsorbed to the stationary phase more than C. Are you getting this? So after moving some distance, A stops because it is having more adsorption tendency. It adsorbs to the stationary phase and stops. B and C does not stop. See, B after moving to a certain distance, now B stops. What is that? B is stopped. So what is this? B. What is this? A. And least tendency to get adsorbed is C. Least tendency to get adsorbed is C. C moves to more distance. If you find, say the solvent moves to very high distance than all these three. See, solvent is moving up to here. Solvent is moving up to here, right? So now, did A, B, C get separated or not? Yes, they got separated. Based on what they get separated? Based on their tendency to get adsorbed. A has more tendency, so it stopped earlier. C has least tendency, so it traveled for much distance. Okay, so who traveled much distance? C. C traveled more distance than B. B traveled more distance than A. So in this way, they got separated. So this is what the thin layer chromatography is. Very much similar to that of column chromatography, but in the column, in the opposite direction, we take. Here we take a thin glass plate. On this glass plate, we are pasting the silica gel or alumina gel. Okay, and the process is continued. Next, let us move to the next part. Looking here, the relative adsorption of each component of the mixture is expressed in the terms of retardation factor, RF value. If you see previous years JEE main or NEET questions, you will find most of the questions from the chromatography based on this RF value. So how to calculate this RF value is very important. How to calculate this RF value is very important, right? So what is RF value? Here you can find it. What is that? Distance moved by the substance from the baseline by distance moved by the solvent from the baseline. Okay. So what is Y? Y is distance moved by, so here you can find distance moved by solvent from the baseline. What is baseline? So this already it is represented here. This is the baseline. So from here to here, it is the distance moved. Y. Y is the distance moved by solvent from the baseline. And what is X? Distance moved by the substance from the baseline. From the baseline. Okay. So if you take how to calculate the RF value, let us see some questions or some calculating RF value of different substances. Okay. So let us take this as baseline. What is this? Baseline. This is baseline. So from here, A moved to a distance of 2 centimeters. What is that? A moved to a distance of A moved to this distance. B moved to this distance, and C moved to this distance, and solvent moved to this distance. Okay. So what is the distance moved by solvent? So let us take this distance. This distance as 10 centimeter. What is this? 10 centimeter. Distance from the baseline. Distance moved by A is 2 centimeter. And distance moved by B. So what is this? A, B, C components moved. So distance moved by B from the baseline is, let us take it as 5 centimeters. And distance moved by C from the baseline. So from the baseline it is 8 centimeters. Then if you are asking for RF of A, what is the distance moved by A from the baseline? 2 centimeter by, and what is the distance moved by solvent? 10 centimeter from the baseline. So 10 centimeter, that is equal to 2 by 10, that is equal to 1 by 5. This is RF of A. What will be RF of B? Retardation factor of B. Retardation factor of B. What is the distance moved by B component? 5 centimeter by, what is the distance moved by solvent from the baseline? 10 centimeter. What is this? Distance moved by solvent from the baseline. Then what do you get? 1 by 2. Then coming to RF of C, retardation factor of C. What is the distance moved by C from the baseline? 8 centimeter. What is the distance moved by solvent from the baseline? 10 centimeter. That is equal to 8 by 10. Okay, 4 by 5. Right? So this is how to calculate the RF. Most questions in previous entrance exam on the chromatography is asked on RF. We need to know how to calculate this retardation factor. Okay. So the spots, we are finding the spots, A, B, C spots, separated spots. The spots of the colored components are visible on the TLC plate due to their original color. See, for example, A is having green color, B is having some pink color, C is having blue color. So if they are colored the compounds, directly they appear in their original colors. But if they are colorless, the colorless compounds which fluorescene means compound which produces color on projecting UV light on it. Fluorescene. What is the meaning of fluorescein? Substance have fluorescence or fluorescein. They fluorescein. The property a substance or a compound exhibiting fluorescence is called as fluorescein. Fluorescence or fluorescein means compound shows color or light. They sparkle, they show color when UV light is projected on it. When UV light is made to fall on it, it will show its color. That property is called as fluorescein or fluorescence. Okay. So if the compound is colorless, but if you impart light or project light or fall the light, UV light on it, if it produces color, then we can find the compound by making UV light fall on it. Okay. Next, spots of the compounds are even detected by allowing them to absorb iodine. Some compounds, if they absorb iodine, they show brown color. So the compounds which when they absorb iodine shows brown color, they are sprayed with iodine. When they are sprayed with iodine, automatically they show brown color. Okay. So every point here is important because they can be asked in the form of statements or assertion reason type questions. So this is this point is important. This point is also important. Sometimes an appropriate reagent is sprayed on the plate. Sometimes amino acids will be there. Amino acids can be detected by spraying ninhydrin solution. Okay, so amino acids when sprayed with the ninhydrin solution, see ninhydrin solution is yellow colored. When it is sprayed on the amino acids, it produces a purple colored compound. Purple colored. The amino acid turn into purple color. It is also called as Ruhiman purple. Ruhiman purple. Purple color is also called as a compound is found that's called as Ruhiman purple. See, amino acids are colorless, but when you spray ninhydrin solution, we are getting purple color. So you can identify that is amino acid. Their amino acid is present. Later on, we will detect what type of amino acid is that. First of all, we will be able to identify that it is amino acid. So amino acids are detected by spraying the plate with the ninhydrin solution. Okay. So let us go with the next part, partition chromatography. Up to now we have seen adsorption chromatography. In that adsorption chromatography, we have discussed two types of chromatographies. One is column chromatography, another is thin layer chromatography. The second chromatographic technique is partition chromatography. The best example is paper chromatography. Paper chromatography. So partition chromatography is based on the continuous differential partitioning of components of a mixture between stationary and mobile phases. So the best example for this partition chromatography is paper chromatography. We have only paper chromatography in our syllabus. Okay. What chromatography is present in our syllabus? Only paper chromatography. So paper chromatography So this partition chromatography is based on this principle. What is that? Continuous differential partitioning of components of a mixture between stationary phase and mobile phases. See, let us take this paper chromatography. This paper chromatography consists of a special paper. Paper chromatography is done by using a special paper. Okay, what is this? Chromatographic paper. What is this? The chromatographic paper. Chromatographic paper. So this is chromatographic paper. So paper is made of cellulose. It is made of what? Cellulose. Cellulose, you know that. This cellulose at the end we will have in cellulose structure, if you find, you will find OH. This cellulose will hold water molecule. What is this OH? OH belongs to cellulose. The cellulose will hold water. This will hold water. This water. Now this water is acting as a stationary phase. What is that? Stationary phase. So stationary phase in paper chromatography is not a paper. Not the paper. We will be getting confused that in paper chromatography the stationary phase is solid paper. No. The stationary phase is liquid water. In paper chromatography, what is stationary phase? Stationary phase is water trapped between cellulose molecules, and what is that? Liquid. Stationary phase is liquid. Are you getting this? You are finding here stationary phase, water. Okay. Now, which is very much similar to that of thin layer chromatography, the setup is there we use glass plate, here we use what? Paper. Same at this baseline, you are finding this baseline, you see. So at this baseline, we are placing the mixture of which is to be separated, and it is dipped in a solvent, and the solvent is what? Mobile phase. What is this? Mobile phase. You are finding chromatographic paper. Now when it is dipped, solvent moves over the paper. Solvent will move over the paper. When solvent is moving over the paper, solvent is carrying the component. Solvent is carrying the component. Let us take it is carrying the component. This is the component. Component A. What is beside? Solvent is beside. So let us take it as solvent. So solvent is carrying this. Along with the solvent, what moves? Component moves. What is this? Component. Component of the mixture. Now this component is having attraction towards solvent, and the component is having attraction towards water. Are you getting this? This part you need to understand. What is this continuous differential partitioning? What is the meaning of that? Simple meaning is that this component is attracted by solvent, it is attracted by water. If this component is more attracted towards water, it will not move to more distance. It will stop because it is more attracted towards water. But if the component is more attracted towards solvent, it will move more distance because it is not much attracted towards water, so it will not attach to the water. Okay. So more the attraction with water, it will move to less distance. Okay, you can make it a note that more attraction or attachment, more attraction with water component of mixture moves to less distance, moves to less distance over the paper, chromatographic paper. Less the attraction, it moves to more distance. This is what called as continuous differential partitioning of components of a mixture between stationary phase and mobile phase. What is mobile phase? Mobile phase is also liquid. Stationary phase is also water liquid. Both phases here in paper chromatography are liquids. So solvent taken is also liquid. Okay. So let us take paper chromatography is a type of partition chromatography. Most of the people confuses that it is adsorption chromatography. No, it is partition chromatography. In paper chromatography, a special quality paper known as chromatographic paper is used. In chromatography paper, cellulose helps as inert support and water absorbed from air onto the hydroxyl groups of cellulose act as stationary phase. So water is acting as stationary phase. Water is acting as stationary phase and the liquid is the stationary phase here. The chromatographic paper spotted with a solution of mixture at the base is suspended in a suitable solvent or a mixture of solvent. The solvent act as mobile phase. Now only we have seen, which is very much similar to that of thin layer chromatography. What you are doing here, you are placing that spot. This is the spot. Okay, mixture of components. What is that? Mixture of components. Right. Now again, what you are doing? You are taking a container here. This is the container. Here you can find the diagram to make it some more clear and drawing again. Now you are placing solvent here. Okay. What you are doing? You are placing solvent. So this is what blue color solvent. The solvent will move over this paper. Moving over paper is nothing but moving over water. Water is the stationary phase here. Paper is not the stationary phase, right? The solvent rises up the paper by capillary action and flows over the spot. It is carrying, as it is flowing over the spot, it carries that components. Okay. Next, coming to the paper selectively retains different components according to their differing partition in two phases. Already I said that. If the component is having more attraction towards water, it moves to less distance. But if the component is having more attraction towards solvent, it moves to more distance. And that is called as differing partition in two phases. The paper strip so developed is called as chromatogram. So this paper, after chromatography technique is completed, you will find separated A like B, like what? C. The paper strip so developed is called as chromatogram. Now they are separated. Now you are drying it, and this paper is called as what? Chromatogram. Is that called as a chromatogram? After separation on the paper, whatever you are finding is called as what? A chromatogram. The spots of the separated colored compounds are visible at different heights from the position of initial spot on the chromatogram. Let us take the initial spot is this one. Initial spot is this one. Okay. So on the chromatogram, you find A moving to some less distance, B moving to more distance, C moving to very more distance. Okay. So the spots of the separated colorless compounds may be observed either by ultraviolet light, this already we have seen, or by using appropriate spraying agent. Already we have seen that ninhydrin reagent. When it is sprayed on amino acids, you get purple color, which is also called as Rohmann's purple, like that. Understood? So this is all about chromatography, the chromatographic techniques. We have seen three. What are those? One is column chromatography, second one thin layer chromatography, third one paper chromatography. Only based on these concepts, application, you are asked in competitive examinations, either it is in JEE or whether it is in NEET. So go through each and every point, go through each and every line, go through complete lecture so that you can understand. I pointed out each and every single point. I explained each and every single point. If you can follow the video properly, then you can understand the concept very easily. Hope so you understood the concepts which are being taught here. In the next lecture, we will discuss another topic. Thanks for watching. Meet you again.